Here's the last section of Chapter 5. It deals with the triangle inequality theorem. This is more of a very conceptual based topic, but this is something that definitely shows up on the ACT. It has in the past. I've seen it on a couple ACTs in the past. And it requires some thinking. So take a minute as we go through it and just pause it as you need to and rewind if you need to as well. So the triangle inequality theorem essentially says the sum of the lengths of any two sides is greater than the third side. So what that means is, regardless of the side lengths, two of them have to add up to the other, have to add up to more than the other one. So if I said that C was 10 and A looks bigger than 10, so let's call that 14. What that means, the triangle inequality theorem, is that B plus C have to add up to more than angle A. If I guessed angle side B was 3, 3 plus 10 is not more than 14, so it wouldn't work. Same with it if I said 4. 4 plus 10 is only 14. That wouldn't work as well. I need at least 5. So the smallest that side B could be is 5. And we're going to go through this. We're going to try a couple different variations, but the reason that this side has to be bigger is I don't have a triangle unless if these two sides add up to more than this side. If this was only 3, 3 plus 10 is 14. Think about if you took a straw that was 3 units long or 3 inches long, a straw that was 10 inches long, you couldn't possibly connect it to both ends of a straw that was 14 inches long. It wouldn't work. You can't physically construct a triangle unless if this side plus this side add up to more than the third. So that's the concept that we're going to be talking about today. So along with this, you can get a range for the measurements. You can have a biggest side or you can have a smallest side. So what we're going to look at first, let's take a look at what if two of the sides of a triangle are 4 and 7. Now again, I'm just picking a triangle just to draw here quickly. It's not going to be drawn to scale. If these were 4 and 7, what could this third side be? Alright, I'm just going to throw out a couple numbers. It could be 5, because 4 plus 5 is bigger than 7. It could be 7, because 4 plus 7 is bigger than 7. It could be 9. 4 plus 7 is bigger than 9. It could be 10. 4 plus 7 is bigger than 10. Where we get into trouble is when I have 11. 4 plus 7 is not bigger than 11. So 11 is the biggest that this side can be, or could possibly be. It can't be 11. It has to be 10. So the biggest side is 10. Oops, want that still. Let's work backwards now and let's find the smallest side. What if I said, let's start from 4. 4 plus 4 is bigger than 7. But if I change that to a 3, 4 plus 3 is 7. So it can't be 7, or it can't be 3 because 4 plus 3 equals 7. So the smallest that side could be is 4. So my sides for this triangle can be anywhere between 4 and 10. Now we're only talking about whole numbers. I realize it could be 3.0001, but for the sake of this unit, we're only going to talk in whole numbers. And it could be 10.5 or 10.8, but let's deal with whole numbers and say it can't be 11 because 4 plus 7 equals 11. So go ahead, try the second one, and then check an answer with me. So this side's 32, this one's 57. Same process, just bigger numbers. Well, what did we do over here? 7 minus 4 is 3. So this number can't be 3. It has to be bigger than 3. So what I'm going to do is I'm going to take 57 and I'm going to subtract 32. If I take 57 and subtract 32, I get 25, which means if I put 25 here, 32 plus 25 is 57, so that doesn't work. So instead of 25, I'm going to put 26. If I try 26, 32 plus 26 is 58, and the triangle inequality theorem says that the two sides have to add up to more than the third. So let's try the other way. That was if I found the smallest possible side. Now let's find the biggest. I'm going to take 32. I'm going to add it to 57. When you add 32 and 57, you get 89. So if I were to put 89 here, we got to see, is that going to work? 32 plus 57 is actually equal to 89. So 89 is not going to work, but 88 will. If I try it, 32 and 57, we know add up to 89, and 89 is bigger than 88. So I have a range from 26 to 88. Now let's try this one. We have a multiple choice, just so you can start to see how this works on an ACT as well. If the measures of two sides of a triangle are 43 and 50, what is the least possible measure of the third side? So we're looking for the smallest value. So I'm right off the bat going to cross off 93 because that's bigger than both of these. So that's not the smallest possible. Let's draw a triangle just to look at it, kind of help us out. 43 over here, 50 over here. So if I'm looking for the smallest possible side, that means 50 is the biggest. So 50 minus 43 gets us 7. Notice 7's an answer. But if I put 7 here, 7 plus 43 equals 50. It's not bigger than 50. So our correct answer is going to be choice 2, or choice B, 8. Try this one. Same process, same strategy. See what you can do if you can get this one right on your own, and then I'll give you the answer in just a bit. So which of the following could not be the measure of the third side? Okay, so we're not looking for the smallest possible. We're not looking for the biggest possible. We're looking for which one is not going to make this work. So what we want to do is we want to start adding. 5 plus 14 is equal to 19. That's bigger than 18. 15 plus 14 is equal to 29. That's bigger than 18. Same with 30, and once I get to 30 though, 30 is now the biggest side. So let's take a look. 14 plus 18 adds up to 32. So is 32 bigger than 30? Yes. Is it bigger than 31? Yes. It's not bigger than 32. So 32 is not possible to be that third side because the two other sides would be equal to, not greater than. 2 more to try. What we want to do is we want to determine, can this work? That's all we're doing. Can this be a possible triangle? Take the two smaller sides. 2 plus 4, 6. Is 6 greater than 5? Yes. Since it's greater than 5, that means this side can be a triangle. Let's look over here. Take the two smaller sides. 6 plus 8 is 14. Is 14 greater than 14? No, it's not, so it's not a triangle.